geometry here. It should be good. Change of pace. Pretty excited. This is some pretty neat stuff here. So we're going to get a bunch of stuff. You may know this, but I want to make sure we have the terminology down. We're going to talk angles. So we know that an angle has the vertex. It's two rays. It's the endpoints of two rays. Boom. So we got these two rays coming out. What you may not know is we call this theta. Theta is this symbol right here. So this is the Greek symbol for theta, and that's how we're going to denote an angle in here. So we're always going to be finding theta. What's the measure of this angle? So we're going to have angles, and we're used to seeing angles like that. We're going to put them in what's called standard position. So that means one side of the angle, we're going to start at the origin, is going to be your vertex, and it's going to extend to the right on the x-axis. So that is going to be what we call the initial side. So I'm going to drag this bad boy up here. That is the initial side of the angle. Then what we're going to do, where it's going to end, maybe it ends somewhere out here. You could probably take a guess. There's my angle right here, and we're maybe finding theta. I want to know what is the measure of that angle. That side over here is called the terminal side, and we are now in standard position here. So standard position, go straight to the right, and we're going to go around the origin here. Awesome. So, quick refresher of quadrants. I may say something weird like, hey, you know, we're used to seeing something like, what is a 48-degree angle? Well, I could draw that in standard position. It goes here. I estimate it something like this. That is a 48-degree angle. What we're going to start doing is saying, what's like a 300-degree angle? So a 300-degree angle is going to be something starting standard position. You're going to go around 300 degrees to this. This is now a 300-degree angle. So also the quadrants here. So another important thing is that remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So sometimes I'll refer what quadrant does the terminal side end up in, and you have to tell me a 300-degree angle ends up in quadrant 4. Let's draw them. I guess on the next page I got some graph paper. Let's draw 315. So almost the same thing. How do I know where to go here? Well, I know from standard position, so this is one side of it. I know that this is 90. It forms the right angle, and a straight line is 180. Add 90 to that. This is 270. So we're looking at, that's 270. So we're going how far past 270? We're going about 45 past it. So we're looking at something like this. This is a 315-degree angle. Excellent. Can we draw negative? Sure thing. So we're starting over here, and I want to draw the negative. Well, this would be negative 180, so I'm going negative 150, and can I ballpark it like this? This is negative 150 degrees. How about 460? Sure. Well, I can go 90, 180, 270, 360. I'm going to go past 360. How far past it? I'm going to go 100 past it, so I'm going to go all the way around, plus an extra 100, so I'm going to end up something like this. Boom. So that is a 460-degree angle. Cool. What if I want you to name some angles here? So if I want to name this angle, yeah, I could name this negative 120. That's too easy. Is there another way to name this? It's going from the standard position negative 120. Sure, I could name it the other way, couldn't I? Well, it's going to got to complete the circle. So check it out. 240 is actually the same thing as negative 120. Fantastic. This one's kind of weird. You know, this is 180 right here. I am 45 away from it. So what is this other part of the angle? How far did I actually go? Well, it's going to be 180 minus 45. We're looking at what? 135 degrees. Very cool. You could also name that negatively. If someone was fired up, could you name it this way? Sure. You could do it that way. You got negative 180 plus 45 more. You're looking at negative 225. So a couple different ways to name these. How about this angle here? So we're looking at, what do you want to call this? Probably the easiest way is to call it this way, a negative angle. Remember, this is like a 90 degrees here, so you're 30 less. This is like 60 degrees, so negative 60, which would be the same as what if I went this way? 30 past 270, 300. So you can name them positively or negatively. Every angle you can name like that, which brings us to my next one, coterminal angle. So coterminal angles are angles that share a terminal side. So in standard position, they have that terminal side in common. So it's just what we were doing on the last one, those were coterminal angles as far as renaming them. So let's say that I give you something like this. This would be the most basic. So let's say that I give you this angle and I describe it as, hey, that is negative 130 degrees. That's a negative 130. Well, I want to know its coterminal angle that's between 0 and 360. So you need to name it positively, so you have to name it the other way. So I don't want negatives. I only want the positive between 0 and 360. A lot of times we just want that positive. So what do you have to do to this? Well, just add 360 to it. I mean, think about it. 360 is the whole circle. Add 360 to it, and we're looking at what? What is this angle over here? Sure, that's going to be 230 degrees. So 230, whoa, let me try that again. 230 is coterminal to negative 130. Awesome. Are there more? Sure. You can name this a bunch of different ways, and we'll come up to that in a second. How about this? What if I give you this angle here? We're looking at this is, say, 130 degrees. So let's say I have a 130 degree angle. Can you name another one that's positive and one that's negative? Well, sure. The negative one, no problem. It's just like the last one, isn't it? That would be negative 230. Boom. No problem. But what about another positive one? Well, what if you went around the circle? Instead of just saying there's 130, what if you went all the way around 360 plus another one of these? So if you add 360 to this, you're looking at what? 490. So these are all coterminal. In fact, I could add another 360 to this and say that's what? 850, I believe. I hope that's right. And then I could keep going, add 360, or subtract 360, subtract 360. You know, if I subtract 360, I could be at negative 590. So I could keep doing that in either direction. Those are all coterminal. Awesome. So if I have this, you know, sometimes I want one positive, one negative, or between there. How do I name every coterminal angle in the world? Well, let's say I give you a 30-degree angle. So this is a 30-degree angle, and I want every single one in the world. Well, that's exactly what I'm going to do. There's 30, but what if I went around this, or I went around again? So what I'm going to do is I'm going to take 30 degrees, and I'm going to add to it what? You're going to add a whole revolution. You're going to add a 360, and that's going to be n amount of times. The key to this is n is an integer. So you kind of have to write that. N is an integer. And what's an integer? Remember, that's a positive or negative whole number. So that depends on how many loops I'm going to do. That was n is one loop. If you put 1 in there, you're going to add it. You're going to get 390. But maybe it's 2 loops. So n is 2. N is 3, N is 4, N is 5, N is 6, and you keep going and going is all you want. Or do the negatives. So that would give you every single coterminal angle in the world we're going to represent by this. So they're all the same thing. So this stuff we're really actually going to use. It's important. It's going to come up in here. Can we go back to this 0 or 360 one? What if I would have gave you one right off the bat? Let's erase some of these notes. What if I would have given you one that was like 960? So what if I, right off the bat, I called this 960? Could you bring that back down to between 0 and 360? Sure, if it's 960, what do you got to do to bring it down? We'll just subtract 360 from it. Does that get there? No, that looks like 600. So I'm still not there, so what I got to do? I got to subtract 360 again. Now I'm in 240. So you just got to work your way into there to get back to 0 to 360. Awesome. Moving on, we're cruising. This is going to be a fast one. So since we're talking degrees, you know, you're probably used to old school measuring things. Remember, we'd have an angle and maybe it looks something like this, and you'd say, oh yeah, well, that's a rough straight line. But roughly that's what? That's like a 45-degree angle. So I would do something like this. We could measure the angle and say, yeah, that's roughly a 45-degree angle. But is that precise? Is that the most precise? Can we get... what about between these tick marks? Like I hit 45 here, but what's in between them? Well, could we say 45.5 degrees? Yeah, we probably couldn't draw that so much with a protractor, but it could happen, couldn't it? You could have these decimals. So how do we, what is really going on here? Well, degrees are pretty cool. They're actually degrees, minutes, and seconds. So degrees are based just like time. I mean, when you think of time, 60 minutes makes an hour, 60 seconds make a minute. This is the same thing. 60 seconds make a minute, 60 minutes make a degree. So a degree is just like an hour. Where these 60 numbers come from, they actually came from the Babylonians. So it's kind of cool. You know, we count with base 10s, you know, 1 through 10, and then we start over. 10 like 11 is 10 plus 1, 10 plus 2, 10 plus 3. Babylonians was base 60, so they would go all the way to 60, then they would start over and say 60 plus 1, 60 plus 2, 60 plus 47. So kind of different, and it turns out 60 is actually a really cool number. They actually were onto something because it's easy to work with. It's divisible by 2, 3, 4, 5, 6. That all evenly goes in there. So these are nice things that go that divide it. So it's pretty easy to work with. And if you want to blame somebody if you don't like the 60, the Babylonians kind of remind me of Mr. Bean because he babbles on and on and on again. Babylon again. Oh man, that's rough. So what are we going to do with this 45.5 degrees? That is actually what? That is actually 45 degrees. What is half a degree? We're going to say it's 30 minutes, just like half an hour. So we're actually going to start using this notation. This notation right here means minute. I'm going to draw a little arrow there. That's a minute. And then we're even going to go down into seconds even farther. Let's see if we can do this. So I'm going to abbreviate degrees, minutes, seconds. We're going to turn them into decimals. So, oh my gosh, that's almost the exact same one. These examples, whew. So we know this one, right? 48 degrees is 48.5 degrees. So it is in degrees, minutes, seconds. So it'll be degrees, minutes. If you notice this, what is this? This is the seconds. So when there's two of them, it's seconds. This is the minutes. And we're very familiar with the degree already. My handwriting is a little rough there. So I want to convert this into a decimal. So how in the world am I going to do that? That was nice because I knew that's a half hour, but this one I don't really know. So here's what I'm going to do. I know I've got my 22 degrees. I'm going to add to it, well, what is 45? It's 45 out of 60. Boom. There it is right there. Plus, I've got 10 seconds, but 10 seconds aren't out of 60. They're out of 60 60s, aren't they? There are 60 seconds in a minute and 60 minutes in a degree, so it's actually out of 3,600. Holy cow, I'm going to need help on the calculator on this, but I'm going to take my 22. I'm going to add to it 45 out of 60, plus I'm going to add to it my 10 divided by, and I'm going to go ahead and put in 3,600. So 60 60s, that's all the seconds in a degree. And I'm going to end up with 22.75. So roughly 22.75 degrees. So that is something that I could graph or try to graph with a protractor. It would be kind of tricky, but you can get in there. All right, why don't you pause it real quick, try this one, see how it goes. All right, here we go. So did you get this answer, 88.445 degrees? Hopefully you did. We're going degrees into 60 seconds in a minute, and then 60 seconds in those 60 minutes is 3,600. So we got that right there. That's pretty awesome, huh? Pretty cool. So that's how you go from degrees, minutes, seconds. So sometimes I'm going to give you an angle, and I'm going to say, hey, this is 48 degrees 30 minutes. So don't freak out if you see that. We're going to use that. It's just more precise. Yeah, it doesn't matter when we're drawing it by hand, but if you're thinking big scale like longitude and latitude, hugely important difference. So if you're talking about, you know, a second or a minute, very big differences. So it is important to be this precise. How about the other way? What if I give you the decimal version of it and I want it back to degrees, minutes, seconds? Can we do that? This one I think is a little bit trickier to see. So I've got this 12. I know it's going to equal 12. Plus, what am I going to have to add to it? Well, I have to take this, I want to know 45.45 is how much of these 60 minutes. So I actually have to say, oh yeah, what is this? So I got to say, what is 0.45 times 60? I know it's around half. So I'm looking at what, 27. So that equals 27. So what did I just find there? Well, I'm kind of going backwards. This is going to be 12 degrees, 27 minutes. So I kind of did the opposite. Instead of dividing by 60, I'm going to go ahead and times it by 60. Pretty cool, huh? How about the next one? It's a negative, so I know it's going to be negative 48 degrees, but I've got this 0.602. So I'm going to times it by 60, and let's see what we get here. So I've got this 0.602 times it by 60, 36.12. So what is this? 36.12. So I'm starting to put this number together. It's 48 degrees for sure. I had this decimal which turned out to be 36 minutes, or really technically, I don't know if don't write this down yet, but really what is this? It's 36.12 minutes. But I don't want that decimal in there. I want to convert that to seconds. So can I do that? Well, sure, you can. You just got to take this 0.12, and it's in minutes already. So now we're just going to times it by plain old 60 because it's already in minutes. Last time we're going back to degrees is why we need that 3,600. So I'm going to multiply this out. What is 0.12 times 60? And that is 7.2. I even did it twice just to make sure. So we've got 7.2 right here. And now I'm kind of stuck. So now what is this? I'm going to say, oh yeah, that is going to be 36 minutes, 7.2 seconds. And I'm not going to break it down any farther than that. I suppose you could add another little slash up there and keep breaking this down, but that's pretty good right there. So we're going to have this. Pretty neat, huh? I'm going to show you something real quick that I think you're going to enjoy, a little shortcut. This is for checking your work here. So this is only for checking. Let's go back to, what? This one right here. 22 degrees, 45 minutes, 10 seconds. Calculator actually does this for you. Right here above apps, it says angle, if you can see that. If you type in second angle, look at that, you've got a degree sign. So really what I'm going to do is type in 88. No, what did I say? I'm going to do the other one, sorry. 22. Second angle, 22 degrees. 45, let's go back in there. 45 minutes, number 2. And 10 seconds. Now this one's not in angle. I'm not sure why they didn't put it in there. But if you come down here to your plus sign in green, there it is. There is the second sign. So you got to hit alpha plus. There it is. Now hit enter. Check that out. And I rounded my answer, and maybe I shouldn't have rounded. In fact, I should not have rounded that. That should have been what? Because I've got that repeating decimal, we should be precise here. 75.27 repeating degrees, like that. Fantastic. So that's a cool way to do it. We'll do the other way for you. This is kind of a tricky way. Can it go the other way? So let's try, what do we say, 12.45? Let's look at that real quick. 12.45 is going to be 12.45. It's already in degrees, but if I go to angle, check it out. Look at number 4, degrees, minutes, seconds. So if I hit enter right here, just hit enter again, it goes ahead and converts it for you. So we were right. Yay, we were right. So that's a great check. I want you to be able to do the work and understand the work, but I want you to check your answers and make sure you get 100%. That's the whole section. Get good at this because we're going to build on it. It's going to be a little trickier next time. I want to make sure we get the vocab, make sure we're good on these angles because it's going to get a little trickier. Good luck on the mastery check. We're going to end with a little more Kevin Bacon here. Peace out.
My favorite actor? Oh, that's easy. Kevin Bacon, obviously. His best movie is probably a tie between all of them. I do a Kevin Bacon impression. This valley's just one long smorgasbord. They're under the ground. It's Tremors. It's of me and Kevin. I've never actually met him. I had it commissioned. Am I obsessed with Kevin Bacon? I don't know. Obsessed is a strong word. I think I'm a devoted fan. And you know, the Logitech review is just perfect for me because I just type in Kevin Bacon and it uses Google TV, finds all kinds of movies and shows and YouTube videos. So let's just say I happen to be in the mood for, I don't know, a movie about a rebellious teen who's living in a town where dancing is illegal. There it is. Let's dance! Yeah, my wife says if I watch any more Kevin Bacon, I might actually turn into Kevin Bacon.
Add Google TV to your television with the Logitech Review.